Okay, let's start today's session with number system. So what are the things we are going to learn in this chapter means, right? So I have taken the mind map, okay, flow charts for the number system. First, introduction. So introduction about rational numbers we are going to learn. Next, how to represent rational numbers in the number system, and density and proof. Okay, density is nothing but, so in between two rational numbers, how many rational numbers it can be. Okay, so how many numbers in between any two rational numbers, so that is nothing but density we are going to learn. Okay, between two numbers. Next we will be learning decimal representation of rational numbers. The next, so irrational number, what is irrational number, introduction part will be there. Then we'll be giving the proof for the irrational numbers like root 2, root 3. Then at the last we'll be having square root spiral. Okay, how to construct square root spiral. So these are the main ideas we are going to learn in number system. The main thing is rational numbers and irrational number. Okay, so this is the overall idea you will be getting about number system. Now, so what is number system? Okay, number system. First, before understanding what is number system, what is number? If anybody asks what is number, you can just always say a number is a mathematical object, is used to count, to measure and label. So what is number system? A number system is a writing system. Okay, number system is a writing system to express the numbers. Okay, how we can express the numbers? The way of expressing the number is called as number system. So here you must know some types of numbers. Up to grade 8 you would have learned some types of numbers like natural numbers, whole numbers, integers, and rational number also is given in grade 8 book. Now natural numbers, okay, what is natural numbers? Okay, natural number means counting numbers are called as natural numbers. It's starting from 1, 2, 3, etc. Why is called as natural number? Okay, naturally we will start counting the numbers from 1. That's why natural numbers we can say. In the natural numbers, if you are including 0, so it will become whole number. If you are including negative numbers, it will become integers. Okay, natural number is starting from 1, 2, 3, right? If you are including 0, so it will become whole number. If you are including negative numbers, so negative numbers, it will become integers. So integers denoted by z. Z means Zelon, which means to count. Right. So next one is rational number. Okay, rational numbers. If the number can be written in the form of p by q, numerator by denominator. The condition is where p and q are integers and q is not equal to 0. And one more extra condition, p and q are co-prime. P and q are integers and p and q are co-prime. So co-prime number means, so two numbers having only one as a common factor. For example, 3 and 7. What is the common factor? 1. 2 by 3. What is the common factor? 1. Okay, two numbers are having only one as a common factor, that is called as co-prime. Okay, this concept we will be using for proving irrational numbers, root 2, root 3 and all. Keep it in your mind. Next, irrational number. If the number cannot be written in the form of p by q, p and q are integers and q is not equal to 0. That is called as irrational number. Next, real numbers. So real number means it includes all the numbers mentioned above. That means natural numbers, whole numbers, integers, rational numbers, irrational number. All these numbers are called as real numbers. So now this is the, okay, under the real numbers. So we will be having natural numbers. Natural numbers starting with 1, 2, 3. If you are including 0, it will become whole number. If you are including negative numbers, it will become integers. And if the number written in the form of p by q, that is rational number. If the number cannot be written in the form of p by q, that is comes under irrational number. So all these numbers are called as real numbers. Okay, all these numbers are called as real numbers. Okay, Next you must know, so what is prime number? Okay, prime number means numbers having only two factors, 1 and itself. If the numbers are having only two factors, 1 and itself is called as prime number. If the number is having more than two factors, it's called as composite number. For example, 4, 6, 8. Okay, these are having more than two factors. So we must know 1 is a factor for all the numbers, and the number itself will be a factor of all the numbers. Okay, whatever number is having only two factors, 1 and itself is called as prime number, 2, 3, 5, 7. Okay, composite numbers having more than two factors is called as composite numbers. Next, co-prime numbers. Two numbers are having only one as a common factor. Okay, one as a common factor for both is called as co-prime number. For example, 1 comma 2. Okay, the common factor for 1 and 2 is 1. Common factor for 4 and 9 is 1. Okay, so these type of numbers are called as co-prime number. Okay, co-prime number. So equivalent rational numbers. So I am just explaining in this class every concept. Okay, based on this concept we will be moving on to the exercise. Okay, so try to understand everything, so in a clear manner. If the concept is clear, whatever question is given we can just solve it easily. Equivalent rational numbers. So we know that 3 by 5 is equal to 6 by 10 is equal to 9 by 15 is equal to 18 by 30 is given. How we can say everything is equal? So everything should be written in the form of simplest form. Then we can say this is equal or not. 3 by 5. Okay, this is the simplest form. Here 6 by 10, we can just simplify it. Okay, simplify both is divisible by 2 table. So 3 2s are 6, 5 2s are 10. So 3 by 5. So 9 and 15 is simplified by 3 table. 3 3s are 9 and 5 3s are 15. Again 3 by 5. So 18 and 13. 3s are 18, 10 3s are 30. Next again you can use 3 table. So 3 2s are 6, 5 2s are 10. Right? So everywhere we are getting 3 by 5, 3 by 5, 3 by 5 in the simplest form. Therefore we can say this is equivalent rational number. Now these all are equivalent fraction which are obtained by, so multiplying or dividing both numerator and denominator by the same number, non-zero number. Here I am just dividing. Okay, both numerator and denominator should be divisible by the same number. If you are using 3 table, use 3 table. If you are using 2 table, you have to use 2 table for the division. Numerator and denominator. Okay, either if you are multiplying or dividing, that should be done for both numerator and denominator. So keep it in your mind. For example, 1 by 3 is given, you have to write the equivalent rational number. So I can just multiply 2 with the numerator as well as denominator. 1 2s are 2, 3 2s are 6. So 2 by 6 is the another equivalent rational number. Another case, 12 by 36 is given. So I want to write the equivalent rational number. For both, 3 table is coming. Okay, for both values divisible by 3. So I can just divide 3 with numerator and denominator. If I dividing by 3 with numerator and denominator, we are getting 4 by 12. Is the equivalent rational number. Again, we can just simplify, right? So both is divisible by 4 table. Okay. Again, if you want, you can just simplify with 4 table, right? So 1 4s are 4. So 3 4s are 12. 1 by 3. This is also equivalent fraction. Okay. In general, okay, similarly, a rational number p by q, we can obtain equivalent rational numbers. How we can obtain the equivalent rational numbers? Right, either you have to multiply with the same value with numerator and denominator, or you have to divide with the same value with numerator and denominator, so you will be getting equivalent rational number. Hope everything is clear, right? So based on this I have taken one small exercise. So express minus 3 by 2 as the rational number with numerator 15. Okay, with numerator 15. Okay, first question. So 3 by 2 is given, minus 3 by 2. I have to write the rational number with numerator 15. Okay, so numerator should be 15. Now, so I have to check what should I multiply with 3 to get 15. The same way, the same number should be multiplied with denominator also. Okay, so 3 into what will be getting 15? So that we will be getting minus into minus is plus.
Plus
Okay, the same minus 5 I should multiply with
2
denominator also. So denominator also. So 2 into minus 5, 2 minus
minus 10
minus 10. Okay, minus 10. Second question is given denominator 10. Okay, so 3 by 2, right? So we have to make the denominator as 10. Okay, I have to make the denominator as 10. So I have to check what should I multiply with 2 to get 10. So 2 5s are 10. 5 should be multiplied with numerator, right? So minus 3 into 5 is minus 15. Okay, minus. Now we have express the number with denominator 10. Now the third question is given. So minus 3 by 2 be with the numerator minus 18. With the numerator minus 18. Okay. So here minus 3 into what we will be getting? Minus 18. So minus 3 into 6. Okay. 6 3s are 18. The same 6 I should multiply here. 2 6 are 12. Okay. 2 6 are 12. Now the fourth question. Okay. Fourth question is the denominator minus 8. So minus 3 by 2, okay, should have the denominator minus 8. The denominator minus 8. So 2 into what I will be getting? Minus 8, 2 into 4. So minus I should get. So 2 into minus 4 is minus 8. So the same minus 4 I should multiply with numerator. So minus into minus it will become plus. 3 4s are 12. Okay, 3 4s are 12. Okay, so this is how we can just finish up this example. This what concept we are using? We are using the equivalent rational number concept. Equivalent rational number concept. So now the next one is the positive and negative rational numbers. Okay, positive and negative rational number. Okay. Here for a given rational number, so make the denominator positive. That is a standard form. Okay, if any rational number is given, so make the denominator positive. Okay, in case if it's having negative in the denominator, so multiplying it by minus 1, then you have to multiply with numerator also by minus 1. For example, if the fraction, if the rational number is having, so 2 by minus 5. Okay, so don't keep the minus sign in the denominator. That should be bring it to the numerator. What they are telling means you have to multiply both numerator and denominator with minus 1. That means what will come? Minus into minus, it will become plus. So minus 2 into 1 is minus 2. This is the normal process. Actually, what will you do? Directly we will taking the minus to the numerator. That is also correct. Instead of multiplying minus 1 by minus 1, so directly bring the minus sign to the numerator. That is a standard form of a rational number. Now check the sign of the numerator. If it's positive, then the rational number is positive. If it's negative, then the rational number is negative. For identifying the given rational number is positive or negative, check the sign. If it's having plus, positive. If it's having minus, then it's negative rational number. In case if both numerator and denominator are negative, for example minus 2 by minus 5, so both are having the negative, then it will become positive rational number. How? Minus minus will get cancelled, so we'll be getting 2 by 5. So 2 by 5 is positive rational number. So we cannot say minus is there, so it's an negative rational numbers. No, minus minus will get cancelled, will be getting positive. Second, here if either denominator or numerator is negative, then it's a negative rational number. For example, if it's having minus 2 by 5, it's irrational number. Or 2 by minus 5, this also negative irrational number. Okay, so this is how we can identify the given rational number is positive or negative. Hope everything is clear. So representing rational numbers on the number line. Okay, representation of rational numbers on number line. So for the number line, how to write the integers? That is very easy. We'll be drawing the number line. We can just mark the integers on the number line. In the number line, we must know that, right? So left of 0, it will be negative, and right side of zeros, it will be positive. Okay, the positive integers are to the right of 0, and negative integers are the left of 0. So in the number line, now we have to represent rational numbers. So p by q format number we have to represent in the number line. So what are the steps you have to follow means, first step, first you draw the number line. Okay, so draw the line first. Okay, draw the line and mark any one point as 0. First you just mark the point 0. First you check this is positive or negative rational number. So both are having plus, so this is a positive rational number. Positive means we are going to take it in right side of 0. Correct? Right side of 0, if you are just marking as this is 0, your answer is going to be right side of 0. Correct? Now next step, see the highest number. Okay, highest number, what is the highest number? 5 is the highest number. So just make the number line as 5 equal parts. Okay, either whatever. Okay, the highest number in the numerator also, we have to see the highest number and make it as equal parts according to the highest number. So here 5 is the highest number. I am going to make as 5 equal parts. 1, 2, 3, 4, 5 equal parts I am just making. Now you just start writing. So this is 2 by 5 we have to mark. So after the 0 we will just write this is 1 by 5. Okay, now this is 2 by 5, this is 3 by 5, 4 by 5, this one is 5 by 5. Okay, 5 by 5. So 5 by 5, yeah, 5 by 5 is nothing but 1. Okay, this is nothing but 1. If you simplify, you will be getting 1. So we have to represent 2 by 5. So 2 by 5, where is it? So now this is our 2 by 5. Okay, so 2 by 5 is here. So this is how we have to represent the rational numbers on the number line. Whatever number is given, first you just consider 0 and check it's a positive rational number or negative rational numbers. If it's a positive rational numbers, number it will be coming right side of 0. If it's negative, we have to take left side of 0 and see the highest number. According to the highest number, make the equal parts and just start writing. You will be easily represent the rational numbers on the number line. Okay, standard form of rational numbers. Now come to the standard form of rational number. A rational number is said to be in the standard form if the denominator is positive. We already discussed. The denominator should be positive and the numerator and denominator have no common factor other than 1. Okay, they should not have common factor other than 1. So what is the another name for this? That is nothing but co-prime number. Simplest form, or we can say the both number should be co-prime. For example, 3 by 4. Okay, it's a standard form. Minus 2 by 11. Okay, so negative values with the numerator, so there is no issue. And 2 and 11 is having only 1 as a common factor. So these type of numbers are called as a standard form of rational number. Standard form of rational number.